Here's our last lesson for our circle unit. It's going to be on the equation of a circle. I'm going to start off with a quick refresher on some equations and graphs that you are already familiar with from Algebra 1. You are familiar with y equals mx plus b. You know that as a line, and we looked at that earlier in the year. Y equals absolute value of x. In Algebra 1, you spent some time looking at that function, that equation. And then you also did a little bit with y equals x squared, which you know as a parabola. This video is going to look at equations of circles. And they're going to be a little different than these. One thing you're going to notice is that it's not going to be y equals something. There's a little more to it than that, because a circle has a characteristic that none of these do. For example, we know what a line looks like. We know what absolute value looks like. We know what parabola looks like. Circle loops back on itself so that one x value has two different y values. And that's going to present a complication. So let's start with a simple version where we have a circle centered at the origin, centered at 0, 0. So here I have a circle. I have the center conveniently located at the origin. I will draw in a radius. This point here is just some value of x, some value of y. And we know that to get from the origin to this point, we go over x and we go up y. Over x, up y. And we end up with a right triangle. X is a leg, y is a leg, r is the hypotenuse. And that leads to the equation x squared plus y squared equals r squared. And this is the equation of the circle centered at the origin. The key thing to remember here, besides the fact that everything is squared, is especially notice that the radius is squared. For instance, if you see this equation and you're asked for the radius, it is not 9. This is r squared. R itself is 3. Some number squared is equal to 9. What number is that? Well, it's this number. This is the radius squared. And again, notice the form of this equation. It's x and y on the same side. The reason we don't write this as y equals something is because this is not what's called a function. And that's a topic that you're going to spend a lot of time studying in Algebra 2, is the concept of function. The short version is, you may remember something called the vertical line test, where if a vertical line goes through a graph and it touches any spot if it hits any point more than once, if it hits more than one point, then it's not a function. So if I draw a vertical line, say here, it's going to touch the circle 2 times. That means that every x value, or that particular x value, has 2 y values. And I can illustrate it here in this quick example. This point down here has coordinate x, negative y. So I have positive x twice with 2 different numbers here. That makes it not a function. Think of a machine where you give it a number and you get an answer. You give it the same number, the machine does the exact same thing, and you get a different answer. Imagine doing an operation on your calculator. You give the calculator a single number, it spits out an answer. If you give your calculator the same number and have it do the same exact thing, you expect the same answer every single time. Well, in this case, you give it the same number and you get two possible answers. That's not a very efficient machine, which means it's not a function. Function is a special type of object, and again, you'll learn a lot more about those in Algebra 2. We're going to keep this equation in this form. X squared plus y squared equals r squared. That is when the circle is centered at the origin. Now we're going to crank it up a notch, because not every circle is going to be at 0, 0. So here's a slightly more complicated example. I have drawn a circle somewhere out in space. Still have an origin. The center, though, is here. To make it simpler, I put it in the first quadrant. Here's the center of the circle, which I've labeled HK. Here's a point on the circle, which I've labeled XY. A couple of things to notice. First of all, the distance x. X is going to be the distance between this point and the y-axis. Or you could say the origin to a spot directly below the point. That's the value of x. To get to this point, I have to go over x, I have to go up y. So y will be this total vertical distance. I can go ahead and label that. There's y. Our ultimate goal is to figure out what these two sides of the triangle are. If we can figure out these two legs of the triangle, we can use Pythagorean theorem and have an equation that we can work with. This is not h. This is not k. H is this distance. It's from the origin to a spot directly below the center. Same thing with k. This is not k. K goes from the center down to here. So, there's our problem. We have this little gap. And we have this little gap. This little gap is the distance, it's the length of this leg. This gap between y and k is the value of that leg. Good news is we can find that gap. I'm going to take this triangle and blow it up a little bit. So here's our point XY. Here's our point HK. And we know this is R. We know that this distance is H. We know this total distance is X. We're looking for this little gap right here, which is also this gap right here. It ends up being the difference between X and H. If I take the total value of X, let's say it's 10, and I subtract H, let's say it's 6, then this has to be 4. It goes back to something we learned a long time ago called segment addition. I have a piece here, I have a missing piece here, and I have the whole thing. How do I find the missing piece? I subtract the whole and a part, and I get this missing part. So this ends up being x minus h. I can do the same thing with this leg of the triangle. I know the whole distance is y. I know this distance is k. What's the gap? It's y subtract k. And now I have everything I need to make the Pythagorean theorem here. So it's x minus h squared. The other leg is y minus k squared. And that's the radius squared. And this is the equation of a circle with center at the point HK. Basically, we took our center and we shifted it over, we shifted it up. Had we gone down here, we'd go right and down. This is right and up. If we go down, we're subtracting a negative number. And when we subtract a negative number, we end up with a plus. So if you ever see a plus inside one of these parentheses, that means that value is really a negative. Because addition is really subtracting a negative. Okay? That is the equation of our circle. X minus whatever the center is, quantity squared, plus y minus whatever the y coordinate of the center is, quantity squared, and then here's our radius squared. What I want you to be able to do is two things. Given an equation, write the center and the radius. Given a center and a radius, write the equation. So let's take a look at a few of examples of each. Let's take a look at these one at a time. Here's an equation. X minus 3, quantity squared, y plus y squared equals 16. Determine what the center of this circle is and what the radius is. The center is always going to be a coordinate. Parentheses required to write coordinates. Without parentheses, it is not a coordinate. So make sure you have those. I see that we have gone 3 units, and that's to the right. What are we subtracting here? Well, we're subtracting nothing. There's nothing here. If we go back to the beginning, when we had just y squared or x squared, that particular coordinate was 0. So we're not subtracting anything. Therefore, the number is 0. The center of this particular circle is 3, 0. This is the radius squared, so the radius is 4. Next example. Quantity x plus 2 squared plus the quantity y minus 8 squared is equal to 64. Center, always going to be a coordinate. Now I have a plus inside of here, which means we had minus a negative. minus a negative, minus a negative 2, y minus 8. Our center is negative 2, 8. Radius squared is 64, which means our radius is the square root of that, 8. Our center, negative 2, 8. Radius, 8. One more example. We have a circle with this equation. Our center is going to be 2, and then be careful here, plus 5 really means minus negative 5. Our center is 2, negative 5. Our radius, since 15 is not a perfect square, our radius is the square root of 15. And if this breaks down, yes, we need to break it down. Square root of 15 does not reduce any further, so this particular one is finished. That is how you get the center and radius from the equation of a circle. And that's what makes this equation pretty slick. We can look at the equation right away, pull out the center, pull out the radius. If we were to solve this for y and make this y equals something, a fun time will not be had by all. This is not a fun equation to specifically solve for y. That's one of the reasons we leave it in this form. It is technically possible to make it y equals. Why you would want to is beyond me, because you lose a lot of that information. What you're going to get is y equals plus minus giant square root with a bunch of stuff. And each square root, you have a positive square root, you have a negative square root. Each of those gives you a semicircle. That's trying to force it into the function version, but you can only look at a half circle at a time that way. This form, the non-function form, allows us to get more information. We get the center and we can get the radius from that form. A few more examples. Now I'm going to give a center and a radius. The goal is to write an equation. So I'm given that the center is 3, 2. I'm given the radius is 2. I'm going to go ahead and write an equation. I know that it's two quantities. Each quantity is squared. And on the right-hand side, I have the radius squared. Well, that's the easy part. Square the number 2. R squared. Now I have to deal with what goes inside. 3 units to the right. X minus 3. 2 units up. Y minus 2. And again, it might seem a little counterintuitive to be going right and writing a minus. Don't necessarily think in those terms. Think of a plus as minus a negative. So then the opposite would be minus a positive. If that makes any sense to you. That always worked for me. I always thought of this as x minus, and then I'm going to write a positive number. I just always thought in terms of opposites. Another way that you could think of this as, if you want to go back to the beginning, so if I want to go from here to the origin, how do I do that? I have to subtract 3. Yep. How do I go from here back to the origin? I have to go down 2, subtract 2. That's another way that worked for me, and that makes a little more sense in a way. The equation will represent how you go from here back to 0, 0. So how do I undo this? I subtract 3. How do I undo this? I subtract 2. The next one. Center 8, -1. Radius is square root 3. Start with my quantities. Square the radius. Square root of 3 squared is 3. How do I go from 8 back to the origin? I subtract 8. How do I go from -1 back to the origin? Well, I have to add 1. Or I can think of it as y minus a -1, and the minus a negative turns into +1. One final example. Circle centered at 0, 5, radius 11. My two quantities. Square my radius, 11 squared, 121. I have x, nothing. And I have y minus 5. And this is not necessarily finished because I know what x minus 0 is. It's x squared. And now I have a slightly cleaner form for my equation. X squared, because there is no horizontal moving. The center is on the y-axis, just 5 units above the origin. No horizontal shift. We shift 5 units up to go from the origin up to here. Y minus 5, quantity squared, and then 121. Make sure you do your completion quiz for this lesson, and that concludes our circle unit. Look for one final assignment for this unit in the next day or so, and then when that is complete, we will start a whole new unit.